I don't know, which one did you do?
Ratio test. On this one.
A to the n plus 1 over a to the n? Yeah, that's the ratio test.
So you take a sub n plus 1 and divide it by a sub n. And when I did that, I multiplied by the reciprocal when you divide. 2 to the n and 2 to the n crosses out, so you get 2n cubed over n plus 1 cubed. That's in indeterminate form, so you do L'Hopital's rule, take the derivative. Got 6n squared times 3 to the n plus 1 squared. It's an indeterminate form again. And take the derivative, get 12n times divided by 6 times n plus 1. And the 12 and the 6 cancels out to 2n divided by n plus 1 is in indeterminate form again. And so take the derivative and you get 2 over 1, which is 2. The 2 is the r. R is greater than 1, so it diverges.
Questions in either steps? That ratio test is a sweet one, right? Nice and simple. All you gotta do is remember the outcome. The hard part is to remember there's 3 outcomes, right? Test fails, diverges, or converges. Now, what's another test we could have used on? I think I told them to use the ratio test on that, right? But what's a test you could have used?
P-series?
Not a p-series because that 2 to the n on top. If it was 1 over n cubed or 5 over n cubed, yes. But with that 2 to the n, you've got a variable on top and a variable on the bottom, not a p-series. Nth term, right? Which is growing faster, the numerator or the denominator?
Numerator.
Which is bigger, 2 to the 1,000, 2 to the 10th, or 10 cubed?
10 cubed.
100 cubed or 2 to the 100th? Exponentials grow faster than polynomials. Exponentials always grow faster. That's not obvious, is it? It's not obvious, but you think about. How can you see that? Well, so the nth term test, let's just go back to the basics. The nth term test, 2 to the n over n cubed. What's going to happen to the top, it's going to be, they're both going to infinity, right? So I'm just doing basically the same, similar work to what Wesleyan already did. If I want to do the nth term test, I don't think it's going to 0 because I think this is going to grow faster than this. But I'm going to check. So the derivative of 2 to the n with 2 to the n ln of 2. The derivative of n cubed, 3n squared. Still going, right? Infinity, infinity. So ln goes to infinity. 2 to the n times ln2 times that constant. 6n. If the terms don't go to 0, the series diverges. Terms do not go to 0, so the sum diverges. Not obvious because it does start out with x cubed below 2 to the x because it's 0, x cubed is 0, and at 0, 2 to the x is 1, right? So it starts out below. And I don't think you can easily solve this. Let's see. Oh, like that. I'm not sure I can find out where they meet. How do I know this one grows faster than this one? I'm getting so old I know things I don't even know why I know they're true. Huh. 2 times 2 is 4, times 2 is 8, 16, 30, 64, 128, 256, 512, 1024. Okay, that's not a very good argument. But you could prove that the derivative of both is positive, right? They're both increasing functions. They're both increasing. And not only are increasing, they're both concave up. So if the derivative of this one, if this one ever gets above that one, it stays above it forevermore. That's a really lousy argument.
Makes sense.
But it's an intuitive argument. So these guys are always bigger than that. That helps when you're looking at ones like this. If you don't have that intuition, then you don't see right away that it's going to diverge. But if you flip it, it's probably going to converge, right? Because if you flip it, the top's not going to grow as fast as the bottom. Okay, who's up next?